All right. Hello. Wait for a little bit. All right on the dot today. Yeah, that should work. Hello. Clear the screen. Anyone there? Well, 1 minute in. Anyone? We got 5 viewers apparently. Okay. Hello, everyone. Yes, we are back. Feels like a while ago. I'm Ming Chow, teaching professor at Tufts University, computer science. Here we are. Yes, we are back after a 1 week absence because last week the student played capture the flag in the course. Um, so today we are going to look at very, very bad code. Very bad code. And then we're going to do something called static analysis. Is anyone in the chat? Hello? Anyone chime in? Someone chime in. I need a volunteer. I need someone to chime in on this. Yeah, it's a weird week because there's a number of students. Hey, Luby. Okay, so Luby. Alright, since you're here, audio check and mic check, I assume that the audio and video are pretty good. Are they good? Hey, Kevin. Okay. How do we sound? Everything sounds good? Okay, all good and all working. Since you're here, so we're going to get started by, I'm going to ask you guys, pick your poison. You want to look at, I'm going to play a game here. I have 3 examples of really bad code. One in Node.js, one in JavaScript, Node.js, one in Java, and one in C. What do you want to see first? What do you want to see first? Go. Actually, this time I'm going to go, I'm going to pick the winner based on first come, first serve. All right, what do you want to see? JavaScript, Java, or C? You want to do Node first, okay. You want to do Node first, okay. So, are you ready? Let's take a look at server.js, which is written in JavaScript. Now, what you're going to do is, all you need to do is eyeball the code and tell me what's wrong. That's the code. Actually, you know what? So that is the code, really short. Why not I show you the actual code? Here it is. I'm in Visual Studio Code. This is server.js. Exactly what you see here. Can I run it? Sure, I can run it. But we're not going to do that. Now, the question I have is, where's the vulnerability? Where's the vulnerability? You can also just pick the line number. Where is it? So cybersecurity relying on insecure HTTP. Yeah, we have that. Okay. So that one's an interesting one because I like that, is insecure HTTP and HTTPS. Yeah, so here's the thing about line number 1 is the HTTP module. There's a module that does HTTP. But here is, we're not too worried about, for this example, I don't know if there actually does Node.js have a require HTTPS? I don't think they do. Let me look. Uh, okay, here we go. Oh, there is. Holy cow. Well, that's news to me. So there is an HTTPS parameter. Oh, a package. I didn't know that until now. Damn. I'm gonna try that afterwards and see if the require HTTPS actually work. Now I'm really interested, but that wasn't the issue that we have in mind. There's something else here. I'm gonna try that after the stream is over. I'm gonna really try. I'm gonna do require HTTPS and not HTTP. Didn't know that was a thing until now. So thank you, cybersecurity growth. Okay, Spooky Monkey, line number 12. All right. So line number 12. Again, we're not even running the code. All what we want to do is we want to eyeball the vulnerability. Where is the vulnerability in the code? And Funky Monkey, you can remove the question mark after line 12. You can remove the question mark because indeed the vulnerability is in line 12. Eval. The use of the eval function. That at this point is egregious. Okay, so have anyone ever used eval before? Anyone have ever done eval? For those of you who do not know eval, I really got to try this HTTPS thing. Thank you, cybersecurity growth. Okay, so here is what the eval function is. It's a very easy function to understand. It's very easy. So let's go to the JavaScript, the eval documentation on the developer Mozilla Developer Network. Now, eval is a function that is available in any programming language. Any programming language, Python, Ruby, JavaScript, C, C++, Java, every programming language has an PHP has an eval function. What eval does, it evaluates, it takes in a string, the eval function takes in a string as an argument and evaluates it as code. That's what it is. So in JavaScript, eval function evaluates JavaScript code represented as a string and return its completion value. The source is parsed as a script. So here's an example. So there's a whole few good examples here. You do a console.log eval, and the string is the input. The eval function is 2 plus 2 as a string. The result is going to be 4. Okay? But you notice that there is a really, really big warning here, and it says executing JavaScript from an arbitrary string is an enormous security risk. It is far too easy for a bad actor to run arbitrary code when you use eval. Never use direct eval as below. Okay? So, what about other programming languages? So, PHP eval. In PHP land, okay, does the same thing. The whole purpose of the eval function is evaluate a string as PHP code. Okay, input is a string, the output is the string executed as PHP. Notice here it says the eval language construct is very dangerous because it allows for execution of arbitrary PHP code. Its use thus is discouraged. If we have to carefully verify there is no other option than to use this construct, then okay, we got a warning here. So let's go to Python eval. And you're going to see a pattern here. And it's the same idea. Python eval allows you to evaluate arbitrary Python expression from a string-based or compiled code-based input. And of course, you can't read a documentation on the eval function without some warning or some serious note about security issues. Come on, man. Here we go. Oh, jeez. Has also security implications. Okay, everything. Every documentation we have seen so far with eval has this huge warning. I'll go so far, there's an old saying in this field called what? Eval is evil? And I like to say that with there's a lot of cases. Eval is evil. Okay? And here it is. And it is a hotly, generally speaking, I like to say eval is evil. Okay? Uh, where is eval used? The only one case I can think of that is a legit use of the eval function is the JSON parsing in JavaScript. I'm, I know under the hood it uses eval, but they have to do a lot of errors, a lot of checking. But generally speaking, if you do a search for eval is evil, you'll see a lot. Okay, you'll see a lot of lots and lots of results. Okay, so yeah, the culprit that we have in mind is indeed, in this JavaScript example, is line number 12, the use of the eval function. Again, you can also say require HTTP because, HTTP now has been, well, for very good reasons. It's like we're moving away from HTTP and using HTTPS. So you can also say that, but the more egregious bad code is line number 12. All right, so we're now down to, again, notice we didn't run this example. We did not run this code in JavaScript, and we don't want to. All you need to do is eyeball the vulnerability. So now we have a choice between Java and C. Which one do you want? Anyone? Someone pick. You want to see the Java or you wanted to see the C code? Pick one. Let me get my water. Alright, so Luby said Java. Let's go. Not the C one. Here you go. Find the vulnerabilities. This one is, well, we're not even gonna run this. And today the whole point is we're not going to run this. We don't need to run this. Where's the vulnerabilities? Actually, let me say, correct myself. Where are the vulnerabilities? What line numbers? And why? And you may be wondering, like, is this a thing to eyeball code to look for vulnerabilities? And the answer is, oh yeah, absolutely. This was how they actually recruited people for Amazon security team. Line 13 and 14. Why is that? Line number 13 and 14. What is the problem, Kevin? Okay, so Matches says 13 as well. Okay, but be more specific. Yeah, I mean, it's unchecked arguments and then executing it, but this also lead to another thing. I mean, you've seen this vulnerability before. Oh yeah, line number 13 and 14, SQL injection, yeah. SQL injection, it is. Yep, that is prime. This is SQL injection 101, lines number 13 and 14. But what's the other vulnerabilities? You gotta get this one. So red flag, 5-alarm fire number 1 is 13 and 14 SQL injection. There's another one as well. Actually, there's another 5-alarm fire here. There's another 5-alarm fire in this code, and there's a whole bunch of other issues as well. So SQL injection, line number 13 and 14, yes, but there's another 5-alarm fire. Which one? Yeah, the hard-coded passwords. But actually, there's even worse than that. So you have lines number 4 and 5. You have the hard-coded username and password. So here's the other thing. You also have a username of root as well. So anytime you use a user as root to connect to anything, they have every single privilege in the world. So you have not one but two serious issues here. You have the hard-coded credential, and then you have a username that is root, where root has super user privileges. So that's, yeah, 5 alarm and that's a 5 alarm fire, both of them if you combine. Um, why is line number 16 a vulnerability? We said 413.14, yes, but why? What's the whole purpose of why line number 16? That's a good one as well. Why? Why is line number 16 a vulnerability? While we're waiting for Kevin to chime in, there's also a couple of other vulnerabilities as well. And these are certainly serious code quality issues. Disclosure of, yeah, the disclosure of results. Can a user see the result? Yes, they can. Yes, you're gonna see all the results. So there's also, of course, no checking of what the results are as well. So you have that for line number 16. The same, if you're going to say that 16 is is an issue, well, then surely line number 20 is a serious problem as well too. Now, line number 20 is another system, is another print line to the console, but it's something even more egregious. It's printing the exception. Here's the thing. For general users, it's never a good thing to print out an entire stack trace or technical details to a general user. You never do that. The more appropriate thing is you log it into a database of some sort, but you never print out. Look at if it were just system.out.println, whoops, something went terribly wrong, and that's it, that's fine. But when you're actually printing out the exception, that's really bad because first of all, that's information disclosure, and quite frankly, any end user should not um, shouldn't see the entire technical stack trace. There are two other vulnerabilities as well. Lesser important, but it's really bad form. I'll give you a hint. Line number 10 is to open a database connection. Even if you've never done database work before, I'm sure when you've done like somehow in your career, in your programming journey, you learn how to open and close a file for reading and or writing. So if you open up a file for reading, what you have to do at the end? Remember, once you open a file, open up anything for reading or for writing, what do you have to do at the end? Yeah, you always close. We don't close the database connection anywhere. We don't close the database. Yeah, there is not a closed connection to database. So a fun story. I used to do this work when I was a software engineer back in the days. So back in the days, we wrote web applications using Java and Apache struts. That's a thing. So I wrote a lot of Java code back in the days, a lot of copying and pasting. And every so often, I remembered on this web app I was working on, like I come into work the next day and it just crashed. Like people just could not connect to it. Um, and the reason was being uh, the database connection. Every time someone opened a database connection, that would be it. The database connection would be just hanging and open. And unfortunately, systems have memory. So what we did was the system opened up way too many database connections and exhausted all the system memory. And so we found out that you know what? There's nowhere here where the database connection is closed. Once we added, you know, a finally block, after the exception handling to say close all the database connection, the problem went away. But yeah, if you don't close database connection, it has real world implication, especially if you're writing a web app that has many users and opens up the database connection for each and every user. So yeah, that could cause a denial of service, if you don't close database connection. The other issue, and this is a code quality issue, is line number one. Import java.sql.star. And it's like, what's the asterisk for? What's the wildcard? The wildcard is import everything in the Java SQL library. And this is a performance issue, and it's also unclean. So you have to have access to every single thing in the Java SQL library, even if you don't use it. So there's a performance issue here. It's just going to load up way too much stuff. So you only want to import the stuff that you absolutely need in order for the program to work. So there's at least 5, 6 like vulnerabilities here where 2 of them are just 5-alarm fires. Okay, and again, a friendly reminder: we didn't even need to run this code. All right, so we only have one example left, and that is a C example. Here's some C code. Where's the vulnerability? I don't care if you are if you know of C or if you don't know of C. Generally, you can probably understand how this code works by the comments. And another hint, the buffer length. Where's the vulnerability? What line number? This is a glaring one. By the end of today, you'll realize one of the outcomes is there are some things that you just cannot do. Yeah, well, really I said line 16, what's the problem? Where's the problem? Like, why? Why line number 16? Yeah, it is line number 16. Have anyone ever programmed in C before? Yeah, it's a buffer overflow. It's a serious buffer overflow problem. Here's the thing, and this is important to know. The C and C++ do not have any bounds checking. You can overwrite buffers, overread buffers, and your program just crashes. There are no provisions built in to defend against those in the C and C++ language. They are built in now at the compiler level, but you are sure as hell okay to, and everyone who have ever written C or C++ code have at least done that before. You know, uh, what is this? If you go back to CWE, top 25, CWE top. Go to most dangerous software weaknesses, out of bound write, out of bound read. We're looking at 2 and 6. Very easy to do in C and C++. And the vulnerability is line number 16. Is buffer 2 has a length of 8. But it also, the idea is copy the first argument into buffer 2. Really what it is copy the input to the command line argument into buffer number 2, which has a length of 8. So if I actually type in a string that is longer than 8 character, blammo, you have what is called a buffer overflow vulnerability. But the problem is, the underlying problem, as I said earlier, is that C and C++, functions, the idea of bounds checking, length checking, does not exist. And in C and C++, there's a number of functions that are called the dirtiest of the dirty that you should never use because by default, they do not have any bounds checking at all. And so if you're going to enter in way more data than what the than what is allocated in the buffer, then your program's going to crash and all these weird things happen. So this is really good article here. This is really good. I gotta find it. Bing! You're gonna like this. So for C and C++, this is a guide from CERN on, really basic computer security. Common vulnerabilities guide for C programmers also applies for C++ as well. And here it is that most vulnerabilities in C are related to buffer overflows and string manipulation. Anyone ever done say? I mean, I'm sure anyone who's written C and C++ code before, you've received a seg fault. Sometimes even specifically, crafted imports can has malicious behaviors. So here is a list of some of the dirtiest of the dirty functions. Gets, get_s. The standard IO get_s function does not direct any buffer length check and will always result in a vulnerability. Mitigation is to prefer using fgets and dynamically allocated memory. Okay, it is what we've just been doing. Stir copy. The stir copy built-in function does not check buffer length and may very well overwrite, the memory contiguous to the intended definition. The whole family of functions are vulnerable. Stir copy, stir cat, stir compare. No bounds checking at all. So the way you mitigate this is one of two things. A lot of times now on various different systems, very different platforms, there is now a bounds checking version of stir copy, which is stir L copy, which if is readily available for you. The other option is you define one yourself that's shown, which does the bounds checking. Another and slightly less convenient way is to use stern copy, which prevents buffer overflows but does not guarantee note termination. Let's go to Microsoft stir copy. And I know they care a lot about this stuff, for real. No snarky comments here. So if you go to Microsoft, and you go to Microsoft Learn, and you take a look at the documentation for stir copy, here's the documentation. Copies a string. They also said more secure versions of these functions are available. Stir copy underscore S, WCS copy underscore S, and MBS copy underscore S. And there's a note right here. Okay? And here, and they even have a bunch of remarks. The stir copy function, copy yada yada yada, because stir copy does not check for sufficient state in the stir destination before it copies it, it is a potential for buffer overrun. Therefore, we recommend you to use stir copy underscore S instead. Yes, to make a short, the TLDR is to use a version of stir copy that is that has bounds checking. I mean, that's full stop. So this is really bad code. Example. But very well done here. So we've looked at a JavaScript example, a Java example code, and a C example code. And notice in each and every one of these examples, we did not even need to run the code. No, we did not even need to run the program at all. We didn't even need to run any of these programs, and you were all able to just eyeball where the vulnerabilities were, what the bad code were. You did that with your own eyes. Again, we did not even need to compile anything. We did not need to run anything. You just had to just eyeball it. And the idea is that idea with to analyze code without even running it is very, very important. Okay? And so now this leads to a conversation of, static analysis. We did static analysis. We just did it. We just did what is called static analysis, analyzing code without even running it. Yes. And so here is a different analysis that we have. So here's what static analysis is. Static analysis is the idea of code scanning. The key point of static analysis, it has absolutely no program execution. We don't need to compile, we don't even need to run. We just eyeball the code and scan. The good news is there's a lot of pros and a couple of cons. A good pro is you're always going to get 100% code coverage. Code scanning is going to look at each and every line of code. You're going to get 100% code coverage, even code that cannot be reached. 100% code coverage. Here's the bad news though with static analysis. Static analysis can generate a lot of false positives. There is there are false positives on styling issues. You get a lot of that, and we're going to see an example of that. Static analysis, because there's no program execution, is not going to find configuration or runtime problems at all. Static analysis can also not prove that there's vulnerability. So it can find vulnerabilities in code, but it can't actually do the exploitation. It won't be able to do that. Okay. Now, there is a plethora of static analysis tools out there. A very simple static analysis tool is one that you probably have used, which is called grep. You can build like a word list of, dirty C functions like stir copy, and you just run that list through a piece of C or C++ code, just see if it's even in there, and there you go. So yeah, you can actually build your own static analysis tool using grep. Like say, for example, just find certain functions, like look for eval, look for stir copy. If you see that, then no, then you got bad code. Another one is called lint. Lint is used to be built into like a lot of compilers. Lint tool called linting. So originally written in C, use what it is just a tool that you just feed in a piece of C code to it, and you're just gonna find any issues. And yeah, it does fall and does find a lot of styling, lots of false positives. Okay, if you ever use Android Studio, there's a linter built in, and it's gonna find a whole boatload of problems with your code. If anyone ever written, if you're in CS 105, which is our programming languages course, have you ever written a type checker? The type checker is a very good example of static analysis. So you may be wondering, why is type checking really a thing? And the answer is yes. And I have a couple of good stories. So for years I taught web programming. And one of the assignments that I had back in the days in web programming was for students to build a map of famous locations or where cars are using Google Maps, using the Google Maps API. You've all seen Google Maps before. So the Google Maps API, and the students have to actually, they actually have to use the Google Maps API. This was before anyone could anyone can actually build a Google Maps with like some random generated key. You didn't even need to log in. Those were fun times. But then people started abusing this. Well, anyway, do you see these markers here? So a marker takes in two arguments, a latitude and a longitude point. So what's the data type of a latitude and longitude? Like if you're filming geography or mapping, what does the latitude and longitude have to be? What's the data type? What does it have to be? Let me see the. go to reference. Oh, that's a places one. Oh. Double or float. Yeah, it has to be a double or float. Oh, they changed this. They changed this a lot. Well, latitude and longitude have to be um, X, Y, a number. Has to be a number. It says it right here. A point is built, a marker takes in a point. A point has to be a number. Has to be a number. If you're feeding in, and I can't tell you how many times, here it is. Latitude in degrees, this means this is yada yada yada. The other thing is, and this is important to know, and this is why type checking is important, and I can't tell you how many times students actually forget to translate latitude and longitude from text to number. And if you're actually feeding into a point, oh, this is long now. A data type that is other than a number, your map will crash. Your map will crash if you do something like, oh, this is a good example. Something like that. 0.1010. This is a string. Map will not load at all. You're going to see entirely gray if you do this. And this is why type checking is important, because it has to be a number, not a string. And so many students in the past have actually fell for this. So yes, this is why type checking is important, because in a lot of cases your app will crash if the type doesn't match what is specified in an API documentation, like if you're using text over numbers for a Google Map point. So what happens if you have like hundreds of thousands, millions of lines of code? Of course, what we've been doing we've been looking at programs that are like a really small. We look at programs, we've been so far, the C, Java, JavaScript examples that we've been looking at are like small and tiny, but what happens if you have millions and millions of lines of code, and you're going to have to resort to using like one of these tools, like a grep or a lint, and there's so many other ones out there, like for Ruby. There's a type checker here's another static analysis tool that's for Ruby's type check, for Ruby type checking. This was built from Stripe, just built by Stripe. Uh, Facebook have created a whole bunch of like static analysis tools. One of them is called Infer. It's a static analysis tool for Java, C, C++, Objective C. This came out during a time when mobile app development was like the biggest hotness. Infer checked for no pointer exception, resource leak, annotation, reachability, you name it. Okay. Um, there's also Brakesman as well too. This is for Ruby on Rails application, find security issues. And now GitHub has static analysis built in. They have their own code. They have code scanning, and you can use any code scanner that you want. I heard things have changed, and now like they make this kind of mandated. Well, at any rate, so these are so many static analysis tools out there. For years in this course, we used Veracode. Veracode, headquartered in Boston, that for application security, find and fix flaws as you is you write code. Um, the issue is there's a whole bunch of like we used to have a gift subscription for this. Unfortunately, there's been some big management changes here, and we no longer, for the last few years, we never had access to Veracode. We used to do this in the security class, which we use Veracode Static Analysis Center, and it's not cheap either, but it did the job. Okay, now there is a new tool that we have, and over the last few years, a lot of students have realized, this is pretty damn good. And I want to introduce you to Snyk. Snyk, S-N-Y-K. They're also headquartered in Boston. Okay, so Snyk, when it was around, or is here it is, Snyk code, and it's a good, really, really good code scanner, static analysis scanning tool. Okay, and for the last couple of years, I've asked students, for the ninth lab, because I give the capture the flag code, I make it available to the course after the game is over. It's like, okay, for an extra credit, scan the code using any tool that you want. And it turns out that most students ended up using Snyk. And I was like, okay, this can't be that good, right? Finally used it at the end of last spring, and it was awesome. I'll give you an example. So now, the free version, and this is all the free version. Every week I get an email. I get an email like this. Oh. In my GitHub repository, for my projects, were the vulnerabilities. No code execution at all. No code execution. Snyk can just find these vulnerabilities in my projects. Another one. I think this happened just earlier. Well, out of bound write. In one of my projects for a dependency in PCRE2. Another vulnerability, which was in the validator library for the not Uber project I have on GitHub. From package.json, that has an improper validation of specific type of input. Okay? It's really, really easy to use. And more importantly, about what is really nice about Snyk is the educational content that is created. So here is, I'll show you. For the ninth lab, students have to do a technical risk analysis of the entire capture the flag game. So this is a communication exercise. But the extra credit is to create and run a static analysis scan of the capture the flag game using Snyk. And here are the instructions. I even provided the instructions here. This is for 0.1 extra credit. But if you do this, then the whole lab is like trivial. And this is getting started with Snyk using Visual Studio Code. So there's a couple ways you can use Snyk. One is just logging into GitHub and just pointing and logging in to GitHub and select which repositories you want to scan. Or the other option is to use this in Visual Studio Code. So I have Visual Studio Code. I'm going to download the CTF game, the source code. I'm going to download it to my desktop. Okay. Now I didn't verify it or anything, but okay, that's fine. So the CTF game file, I gave you the entire source code of, a lot of PHP files, database. Oh yeah, even all the database files are here. Don't need this. I'm going to fire Visual Studio Code now. Okay. Don't need this. Yeah, I'll just save it. So what I'm going to do is I'm going to do, okay, so I go to Extensions, install the Sneak Security plugin. So all you had to do is just install the plugin, log in. I logged into my GitHub account, open folder. I'm going to open a folder on my desktop, CTF 2025, fall 2025, open it. Yeah, why not? And then I got a warning that said, while scanning may automatically execute code such as invoking package manager. You should only scan folders. Okay, I'm going to trust folders and continue. So Sneak Veracode does both. And here it is. So I click on the Sneak icon here, and it's doing my scanning. So it's going to do code scanning right now, no AI. Okay, it's not going to do any code execution. So again, it's just, you can see it right here, code, Sneak code, scanning the entire folder. So it takes a few minutes. No configuration issues just yet. No open source security issues just yet. But it's still scanning. And watch what happens. So we're going to let this thing run. And while we're here, while we're waiting for this, we'll have a window here. We'll let it. Sneak also has like really good learning resources called Sneak Learn. So interactive secure development lessons here. Oh, here we go. 336 issues. Well, SQL injection. You've done that. Oh, here we go. Look at this, 336 issues. So we're not using the AI agent at all. There are no issues fixable. Yeah, we're not going to use AI. So let's go to board.php, cross-site scripting. You already know a lot of these things. CWE79, cross-site scripting. Found it. Line number 51. It even tells you how to fix the code. Found SQL injection. CWE89. We've gone over this before. Another SQL injection. You can even learn. Let's go to learn more about this type of issue. There you go. What is SQL injection? SQL injection. I feel like this is, well, it's pretty nice that it's kind of regurgitating or kind of like reinforcing everything that we've learned so far. It's one of the most widespread code vulnerabilities. To perform a SQL injection attack, the attacker inserts or injects malicious SQL code by way of the input data of the application. You can have a lesson here. If you ever want more training stuff, and we'll go over this after Thanksgiving on the last day of class, like where do you go from here? Sneak Learn is a really, really, really good resource on application security. Now, they do application security only, not with network security, not forensics, not malware, but if you're like if you like coding, if you like software development, software engineering, and that stuff, like this is the content for you. They have the examples, yeah. So let's go to another one, another SQL injection. So yeah, I'm not even paying for this. This is the free version. Information disclosure. CWE 200 or CWE 209. Maybe I do need a bigger screen. Yeah. I don't need this fucking agent here. There you go. So it even shows you. So Sneak will give you. It will show you where the vulnerability is, what the vulnerability is, where it is, and also it will correlate with the CWE. And for this lab, um, you basically just have to build yes, a table of all the risk in the game. So a good example is you build like a, number one, like brute force, CWE, brute force to login, to find Bobo, technical risk indicators, it's related CVE or CWEs, the impact rating, which is your call. But if you do the static analysis scan, this lab is just trivial. This lab is just trivial. So I want to give a shout out. Of course, I haven't done this yet. I want to give a shout out to Sneak for their work on finally. This has been a pain point for me for over a decade. Was like, you know, most computer science students don't even know this. Haven't even used static analysis tools. But look at here we are in the year 2025, and if you're writing code and you're not using a static analysis tool of some sort, that's not okay. It's like, you know what? If you're building software without using Git these days, then that's not okay. Uh, Unfortunately, even up to this day, like we still face SQL injection, cross-site scripting vulnerabilities, and hell, there's a whole crop of generation of developers don't even know this kind of stuff. Okay, you can see all the you can look at this. Whew. So much stuff. So many. Yeah, it just now, all 336 issues, do you want to document that in the table? No, only the important ones. Also, and this is one of the problems with static analysis tools, is if you have a really large code base and you're using a tool like Sneak or, you know, any other static analysis engine, you're going to see a lot of issues, like lots and lots and lots of issues. Sometimes you actually have to say, hey, this is not even an issue. So you really have to go and you have to take a look at them for yourself. But here, it's also pretty nice that Sneak actually, prioritize them. Like, yeah, cross-site scripting, SQL injection, a very high vulnerability. That's why there's an H icon here. Okay. Um, so using a static analysis tool, really what I want you to do, and this is why I give the 1.1 bonus, is you really want to start getting into the habit of a static analysis tool now. Which also leads to another fun item. I want to go back and I want to talk about, just very briefly, the idea of dynamic analysis. Now, dynamic analysis is, it's a little different. Dynamic analysis, unlike static analysis, is runtime. It requires the execution of code. Okay? So it's like, what? Yeah, so here's the thing about dynamic analysis and the different. I'm going to close the folder. Yeah, I'm going to close the folder. But I can go back. You need to run the application. You need to run the code. Like, for example, you have to run the tool on a running version of A.out. The good news of dynamic analysis is it can find configuration issues. The bad news is it's not a code scanner, so it's not going to have 100% code coverage. So you may be wondering, like, have you ever used dynamic analysis before? And the answer, of course, I hope you did. Do they still do this for those of you who are chiming in? In the Introduction to Computer Science and Data Structure courses at Tufts, do they use Valgrind? Valgrind. The most famous static analysis tool. Dynamic analysis tool. You got a Valgrind, it checks for memory leaks. There it is. Dynamic analysis tool. They still use, do they require the use of Valgrind in the intro courses? Anyone chime in? I hope so. Yeah, yeah. So, take a guess. Who was the one? Does anyone want to take a guess? Who was the person responsible for requiring Valgrind in the data structures course? Anyone want to take a guess? Take a wild guess. Who required the use of Valgrind in data structures? Take a guess. Take a wild guess. There's a fun story behind this. It is me. So I taught data structures 2000, 2011 to early 2013. I had a lot of fun. They don't want me to teach data structures anymore because I'm too practical and I don't give like the theoretical background. But I had a lot of fun and I don't regret a minute of it. So for years, the jump from the intro course to data structure was huge. But then the jump from data structures to our third course, which is the machine language course, Comp 40, was an abyss. Like that jump was an abyss. And so one of the things I said, you know what, in order, people need to be better prepared to go to a course like CS40, our machine structure and assembly course. And it was Norman Ramsey who introduced and required the use of Valgrind for CS40. I wasn't the first one, but it was Norman. And I always thought that was an amazing idea. It was it's a great thing because you know what? It is not okay to dump core and, have seg faults and to print out error messages. But yeah, like if your code just bombs and seg faults all the time, that's like you get a zero. I think in CS40 days, I hope they still do that. Like if you get seg fault or you dump core, like you get no credit for your work. I like that is something that we have to do. Um, and so Norman introduced for Valgrind for CS40, and I always knew the jump was pretty big from 15 to 40. And I was like, you know what? I don't care. I'm gonna actually require the use of Valgrind at the data structures course. And here we are. So the idea of Valgrind being used in the intro courses, like Intro to Computer Science and Data Structure, yeah, that was me. But I have to give credit where credit is due. I stole that idea from Norman Ramsey when he built the course. When he built CS40, I think it was like in 2007 or something. Um, I've stolen so many great ideas from Norman, such as the incorporation of using Git into classes. That worked out a little bit too well, let's say. But yes, Valgrind is a dynamic analysis tool, a quintessential one that I'm sure, like if you write C and C++ code these days, you can't, you know, work without Valgrind. And I hope people gotten into the habit of that. The same idea, if you're building any code for using any language, you got to use a static analysis tool like a Sneak, like a Sneak, for example. It's so important. So here's an idea of dynamic analysis. Now we can actually run code, and I can show you a few bad examples now. So I'm going to compile the Vone.c example. Yeah, I got one. So I'm going to do just a review of Vone.c. Now this is what happens. So it does take in command line arguments. There you go. B buffer underscore 2 is, okay, so far so good, everything looks okay. Now I entered in, what was my input? AA, 3A, 3 lowercase a's. Buffer underscore 2 now contains 3 lowercase a's. Okay, so far so good. Well, 4 lowercase a's. Okay, nothing bad, everything's so good. Buffer underscore 1 is a 1. 5 a's. Okay, everything looks good so far. 6 a's. Alright, everything looks good so far. 7 a's. 7 a's. Buffer underscore 2. Buffer underscore 1 still looks normal. But remember, if you remember the Vone.c code, buffer underscore 1 and buffer underscore 2 have a length of 8. Let's run this again. Well, now what happened when we have 8 A's? Uh-oh. Uh-oh. 10 A's. Uh-oh. Buffer underscore 2 and buffer underscore 1 look really, really messed up right now. Let's add the more A's that we get. Remember, buffer underscore 2 and buffer underscore 1 should only have like 8 characters. 15 bytes is bigger than 8. And so you're going to have a spillover into from buffer underscore 2 to buffer underscore 1. Oh shit, now you have an overflow into value as well too, because that was consistent for a while. But you actually notice now that even value is looking wonky. You see a whole bunch of 616161. Anyone know why? You see a lot of 616161s there? That's because 61 is the alpha, is the ASCII value for lowercase a. So eventually, if you actually enter a whole bunch of A's, now you got a segfault. That's not good. So this is buffer overflow. This is what happened when you actually use functions, insecure functions such as stir copy. So actually, that being said, I want to go back here for a second. So now I want to open up the folder of bad code that I have here. So I'm just going to do a sneak on this mess. What? Yeah, I want to trust that. Look at this. Oh, that's funny. What the hell? Twitter test, SQL injection, hard-coded credentials. Look at that. Oh yes, I forgot the fix. What's the fix for hard-coded credentials? When you're in the future, you never want to hard-code credentials. What you do want to do, I'm surprised that the C function, well, the C stuff is not here. If you have secrets such as like credentials and URL, you put them in what is called environment variables. Okay. Do not, is it safe to store passwords, environment variables? Well, in favor is avoid version control. So one way, I think Heroku has it. This is a really good example. Configuration and configuration bars. So the idea is you just want to store like GitHub username, GitHub password in, a key value pair store that's on your system. You can put this in memory. You can put this in, your settings, database URLs. So, or you can put it like an external environment file. How to handle secrets. Yeah, store credentials in another like file, like a .env, and then import it. So this is a Python example. So never hard code credentials, never hard code username. Store them in a separate file or save them into memory, and then just have your Python program or whatever code that you're using just import them. So that's how you just resolve that problem. Oh yeah, you may be also interested in why is server.js vulnerable. Well, I'm doing this. What's the IP address on this thing? All right, 247. Okay. So I'm going to run node server.js. The server is on. No. I'm going to open up a new tab. I'm going to do, oh, that looks weird. Alright, curl minus data. We're doing an H blah. Oh yeah. Got some data, blah, and end. Alright. So I'm going to send data to the server that is running at okay. But now our goal is there a way that we can just shut down the server? We could. What is the vulnerability here? Clear text, hey, clear text transmission using HTTP. So cybersecurity, who was it? Cybersecurity growth is absolutely correct. Clear text submission. Hey, look at that. Never said you were wrong. Now just prove that you're completely right. CWE 319, thank you. Cybersecurity growth, yes. But what we're trying to do is we're trying to crash the server. Eval some data. Hey, what happened if we did this? What happened instead of a real we do something like a real, we'll put in a string that's real Python code. Console.log hi. Okay, maybe that doesn't work, but what happened when we do console.log hi without the semicolon? Ooh, we finally got it. Had to do a hit control C. What happened if I do a console.log? Hey, by the way, I want to take a look at this code again. Request and response are objects. I just want to console out the request. Shit, that's a lot of data. Now, if I want to crash the server, I can do like I think process.exit. Bam. Got some data. So the Node.js program is going to actually process this as JavaScript code. Process.exit is the killer running program, and program crashes. Game. Okay, so that's why eval is not a good thing. Moral of this story is never ever use eval ever. Seriously, even know if you know what the hell you're doing, just don't use eval. So yeah, we've done static analysis and dynamic analysis today. Static analysis, no running of the code, just eyeballing or code scanning. Dynamic analysis is running the code, and then you find all sorts of interesting issues, including like memory leaks, etc. And then we also use Sneak as well for static analysis, and that should be incorporated into all of your development, like your software development and software engineering pipeline. So, folks, that is it for today. But you may be wondering, where does this lead to? Well, there's a very good reason why today is static and dynamic analysis. So you've learned a lot in this class so far. You've learned quite a bit. You've learned about vulnerabilities. You've learned about networking and network security, or lack thereof. You learned about HTTP and encryption and why that is bad. You've learned encryption. You've learned web security galore, SQL injection, hard-coded passwords, cross-site scripting. You've even done sniffing and scanning. And today you've done dynamic and static analysis. And all road, everything lead to one final topic next week. A big one. Because you cannot learn about malware. We cannot do malware if you're not familiar with the term static and dynamic analysis. And that's it, folks. Yeah, that's all for today, and we'll see you next week when we do malware. Yes. All right. Yeah, sneak code is good. No, I don't want to actually install the extension pack. You know, one thing I do miss about Visual Studio Code is all the plugins. I really do miss that. I really miss the plugins. This is nice, though. Yeah, I can see why students actually. Wait, what's the scan failed for? I can totally understand why students like swear by this. Four issues: hard code password, hard code password, hard code passwords. Yeah, I'm gonna close this now. Close the folder. Yep, I got sneak here. Open up the folder. All right, folks. Take care. Yes, see you next week. Yeah, it's been a while. You know, good thing that I finally am using sneak here. Yeah. Take care, everyone.